Geography, the study of Earth's physical features and their impact on human activity, plays a crucial role in shaping our world. From ancient civilizations settling near rivers to modern cities built around harbors, our environment dictates how we live, work, and travel. This influence is especially evident when we examine the location of airports, those gateways to the sky. Airports, unlike many other structures, demand a unique set of geographical considerations. They require vast expanses of flat land for runways, unobstructed airspace for safe takeoffs and landings, and favorable weather conditions to ensure smooth operations. Moreover, their accessibility to major cities and transportation networks is paramount. This essay delves into the intricate relationship between geography and airport locations, exploring how physical terrain, weather patterns, and accessibility shape the design, operation, and strategic importance of these aviation hubs. Through real-world examples, we will uncover the challenges and opportunities presented by geography and understand why certain locations emerge as ideal spots for these modern marvels of engineering. As we navigate this fascinating landscape, we will discover that airport location is not merely a matter of finding a suitable patch of land. It is a delicate balancing act, a testament to human ingenuity in harmonizing our desire for air travel with the constraints and opportunities presented by the natural world. At the heart of every airport lie the runways, those long stretches of pavement that serve as the launching pads and landing strips for aircraft. The construction of these critical infrastructures necessitates large swathes of flat, unobstructed land. This fundamental requirement immediately eliminates mountainous regions, densely forested areas, and urban centers with limited space. Flat terrain offers several advantages. Firstly, it provides the necessary length for runways, allowing aircraft to achieve the required speeds for takeoff and have sufficient distance to decelerate upon landing. Secondly, it minimizes the risk of turbulence caused by uneven ground, ensuring a smoother and safer flight experience for passengers. Open skies, devoid of tall buildings, mountains, or other obstacles, are equally crucial. They provide pilots with clear lines of sight during takeoff and landing, reducing the risk of collisions and enhancing overall safety. Additionally, unobstructed airspace allows for more efficient air traffic control, enabling a higher volume of flights to operate safely. The search for flatlands and open skies often leads airport planners to consider locations on the outskirts of cities or in rural areas. These locations, while geographically suitable, pose challenges in terms of accessibility and connectivity. Striking a balance between ideal terrain and convenient access remains a constant consideration in airport development. While flatlands are ideal for runways, mountains present formidable obstacles in the world of aviation. Their towering heights restrict airspace, create treacherous wind patterns, and often bring unpredictable weather conditions. These factors make mountainous terrain a significant challenge for airport location and operation. Mountains disrupt the smooth flow of air, creating turbulence and downdrafts that can pose serious risks to aircraft, especially during takeoff and landing. These unpredictable wind patterns, known as mountain waves, can cause sudden changes in altitude and airspeed, making it difficult for pilots to maintain control. Moreover, mountains often experience rapid weather changes, with clear skies quickly giving way to fog, low clouds, and precipitation. Such unpredictable weather conditions can significantly reduce visibility, making it dangerous for aircraft to operate. The presence of mountains also limits the availability of suitable land for runways and airport infrastructure. Building in mountainous terrain is inherently more expensive and complex, often requiring extensive excavation, tunneling, and reinforcement to create a stable and safe environment. Despite these challenges, some airports have been successfully built in mountainous regions. These airports often feature shorter runways, specialized navigation systems, and stringent weather monitoring to mitigate the risks associated with such challenging terrain. Weather plays a pivotal role in airport operations, influencing everything from flight schedules to runway selection. Airports located in regions with frequent fog, heavy rain, thunderstorms, or strong winds face significant operational challenges and potential delays. Fog and low clouds reduce visibility, making it difficult for pilots to navigate during takeoff and landing. Heavy rain can create slippery runways, increasing braking distances and potentially leading to hydroplaning. Thunderstorms bring lightning, which poses a direct threat to aircraft, and strong winds can cause turbulence, making it unsafe for planes to take off or land. Airport planners carefully consider historical weather patterns when selecting locations. They analyze years of meteorological data, including wind speed and direction, precipitation levels, visibility, and temperature fluctuations to assess the suitability of a particular site. Airports in regions with challenging weather conditions often invest in advanced meteorological equipment and infrastructure to mitigate weather-related disruptions. This includes sophisticated radar systems for early storm detection, instrument landing systems to guide aircraft in low visibility, and runway de-icing equipment to combat winter weather. While weather remains a powerful force, technological advancements in proactive planning have significantly improved our ability to operate airports safely and efficiently, even in the face of challenging meteorological conditions. Section 5. Access is key connecting cities to the world. An airport's proximity to major cities and transportation networks is crucial for its success. Airports serve as gateways to the world, connecting people and businesses across continents. Easy access to and from the airport is essential for passengers and cargo transportation. Airports located close to city centers offer convenience for travelers, reducing travel time and transportation costs. However, such prime locations are often limited in space and face restrictions on noise and air pollution, hindering expansion and operational flexibility. Airports situated further from urban areas benefit from ample land availability and fewer environmental constraints. However, they require efficient transportation links such as highways, railways, and public transportation systems to ensure seamless connectivity to the cities they serve. The development of robust transportation infrastructure around airports is crucial to facilitate the movement of passengers and cargo. High-speed rail lines, dedicated airport expressways, and efficient public transportation systems play a vital role in enhancing accessibility and reducing congestion. In recent years, the concept of aerotropolis has emerged, where airports serve as the nucleus for urban development. These self-contained cities integrate business parks, hotels, convention centers, and residential areas around the airport, leveraging its connectivity and infrastructure to create thriving economic hubs. Section 6. Case Study: Denver International Airport, Battling the Elements. Denver International Airport, located on the high plains of Colorado, exemplifies the challenges and triumphs of building and operating an airport in a geographically challenging location. DIA's story is a testament to human ingenuity in overcoming the obstacles posed by nature. Situated 25 miles northeast of downtown Denver, DIA was built on a vast expanse of flat prairie land, ideal for runways but notorious for its harsh weather conditions. The region experiences strong winds, blizzards, and extreme temperature fluctuations, posing significant operational challenges. To combat these elements, DIA boasts 6 runways, including the longest commercial runway in North America, to accommodate for reduced aircraft performance in thin air at high altitudes. The airport invested heavily in snow removal equipment, including a fleet of snowplows, de-icing trucks, and a sophisticated ground-based heat system to keep runways clear during winter storms. DIA's iconic peaked roof, resembling a series of snow-capped mountains, is not merely an architectural flourish. The Teflon-coated fiberglass fabric allows snow to slide off easily, preventing accumulation that could collapse the roof under its weight. Despite the challenging weather conditions, DIA has become a model of efficiency and resilience, demonstrating that with careful planning, advanced technology, and a deep understanding of the local environment, airports can thrive even in the most demanding of locations. Section 7 Case Study: Gibraltar Airport, a runway shared with the city. Gibraltar Airport, located on the Iberian Peninsula, presents a unique case study of how limited geographical space can influence airport design and operations. The airport's runway, the only one in Gibraltar, intersects the territory's main thoroughfare, Winston Churchill Avenue, creating an unusual situation where road traffic is halted to allow aircraft to take off and land. The scarcity of land in Gibraltar, a British overseas territory bordering Spain, left no other option but to build the runway across the narrowest point of the peninsula. This unusual layout requires close coordination between the airport and local authorities to manage road traffic and ensure the safety of both drivers and air travelers. When an aircraft is preparing to take off or land, barriers descend. Traffic lights turn red and vehicular traffic comes to a standstill, allowing the runway to function as part of the airport. Once the aircraft has cleared the road, the barriers are lifted and traffic flow resumes. Gibraltar Airport's unique situation highlights the ingenuity and adaptability required in airport design when faced with extreme geographical constraints. It demonstrates that even in the most limited of spaces, air travel can be facilitated, albeit with unusual and innovative solutions. Section 8. The future of airport location balancing geography and growth. As air travel continues to grow, the demand for new airports and the expansion of existing ones will intensify. However, finding suitable locations will become increasingly challenging as urban sprawl consumes available land and environmental concerns gain prominence. Airport planners will need to adopt innovative solutions, such as building on reclaimed land, constructing floating airports, or even exploring underground options. These futuristic concepts, while technologically feasible, come with their own set of challenges and costs. Sustainability will be paramount in future airport development. Reducing noise and air pollution, minimizing water usage, and integrating renewable energy sources will be crucial to mitigate the environmental impact of aviation. Moreover, airport development must prioritize accessibility and connectivity. Integrating airports into existing transportation networks through high-speed rail lines, dedicated bus lanes, and efficient public transportation systems will be essential to ensure seamless travel experiences. The future of airport location will require a delicate balancing act, harmonizing the growing demand for air travel with the need to preserve our environment and enhance the quality of life for communities surrounding these vital transportation hubs. Section 9. Conclusion. Geography's enduring impact. From the flat plains of Denver to the confined space of Gibraltar, geography exerts an undeniable influence on the location, design and operation of airports worldwide. The availability of suitable land, prevailing weather patterns and accessibility to transportation networks are all critical factors that shape these gateways to the sky. As we have explored in this essay, airport location is not merely a technical decision, but a complex interplay between human ambition and the realities of our physical environment. It requires careful planning, innovative engineering, and a deep understanding of the local geography to create airports that are both functional and sustainable. As air travel continues to grow, the challenges posed by geography will only intensify. However, with ingenuity, adaptability, and a commitment to sustainable practices, we can continue to connect the world through aviation while respecting the delicate balance of our planet. The story of airports is ultimately a story of human ingenuity in overcoming geographical constraints to achieve remarkable feats of engineering and connect the world through the miracle of flight.